Hi, I'm Peter O'Shaughnessy. I work in the Future Tech team at Pearson, and I would like to talk to you all today about WebGL, the API that lets you do amazing 3D graphics in the web browser, and specifically how you can do that and control it through the library that we all know and love, React. So first of all, you might be thinking, well, WebGL, we've been hearing about that for a while. I've been seeing demos for a couple of years now, but can we actually really use it? So the first thing I want to say is that actually the support for WebGL now in the browsers is pretty good. As of iOS 8 last year, it's now supported in all the major browsers across desktop and mobile. And in case you're wondering about the different greens here with the partial support, so the partial support here means that it's supported in the browser, but it does still depend on your graphics chip or your graphics drivers. But even with that caveat, the numbers are pretty good. Sorry, it's cut off a little bit there at the bottom, but hopefully you can see that about 89% of users now have support for WebGL, according to WebGLstats.com. And you can see how that's changed over the last couple of years, especially with the jump now from what was deemed the experimental version of the API to the stable version now. So actually using WebGL now is pretty feasible. And also on mobile. And so I picked out a couple of examples that I'd really like to share. These are ones that I especially like because they're responsive and they work well on mobile as well as desktop. I don't have the Wi-Fi, but I've got a video showing this one on mobile. I just will bring that one up. I've got a few videos ready. So here it is on my Android phone. And you can see that there's a nice kind of whizzy loading animation and everything goes nicely spinning around there. You can start the visualization. I should say that this is a website that's telling you about a Bitcoin reserve, and you can see the graph on a nice whizzy 3D globe there, spin it around with the touch controls, and you've got filters that you can apply. And on desktop as well, this works in a similar kind of way, but just you can imagine it scaled up and it has extra data that comes down on the sides as well. So that's one I like. Another one I picked out, some of you may have seen this one, PabloTheFlamingo.com. So let's show you what that one looks like. Unfortunately, I don't have the sound on this because I was recording the video in the office and I thought I wouldn't annoy all my co-workers. So imagine a funky tune in the background. Yeah, thanks, someone's doing the sound effects, great. And so you have Pablo there dancing around, having a good time. But he gets angry if you turn the sound off. And he switches it back on again, and there he's nice again. There you go. So I like that one for, again, you're working on desktop and mobile, and how powerful the 3D graphics are on mobile. The next thing you might be wondering, WebGL is really low-level API. It's not very easy to work with, is it? And you would be right. Just to share an example of the easiest thing that you can actually do in WebGL, which is to draw a triangle. I thought I'd share the code for that. But I'm not going to go into it line by line because really I just wanted to show you that there's 3 pages worth of code here, including our vertex shader and our fragment shader. And all in all, I think it was about 38 lines of code for a triangle. So that's a bit of a pain, especially if you're not an OpenGL developer or used to these low-level graphics APIs. So thankfully, there are libraries that you can use on top of WebGL that abstract you away from most of that complexity. And 3GS is one, and it's probably the most popular one. It's the one that I use as well. And the examples that I showed you earlier were created with 3GS as well. I think you can just about see Tableau up there. It's one of the demos that they show on the website. And so I want to share just a quick example of doing something with 3GS in case some of you are new to it. Actually, can I just ask you to raise your hands if you've done something with 3GS already, just to get a sense? Okay, great. So, fair few of you, but probably not most of you, so great. So, I just want to do a kind of quick Hello World-ish kind of thing with 3GS, which is making a spinning cube with, of course, our React logo on it. So, there's a bit of code here, but let me walk through it. We've got 4 things to do before we actually get to our actual cube that we want to create. So the first thing we do, top there, hope you can all see the code well enough, is to set up our WebGL renderer. So this is something that 3GS gives us that is actually going to be responsible for rendering out to our WebGL canvas. So we can set a size on the renderer there, and with the renderer we can either pass it a canvas that we want it to spit out into, or just let it create its own one. And that's renderer.dom element, and we can take the canvas that it's going to spit out and append it wherever we want in our DOM. So here we just put it in a container. Then we have a 3GS scene. So this is essentially your kind of world-like concept. It's the container that you put everything else inside, your camera and whatever objects you want to place in the scene. So we create that. Then we have our camera. Now the camera is our viewpoint into the scene. If you haven't done anything with 3D graphics, that might be novel at first, but it's really nice, especially then, for example, you can change the scene just by moving the camera around and changing the perspective. So then we add that into the scene. And then we load up our texture, our React logo that we want to apply to the cube. So now we're on to the actual cube. And in 3GS world, this is called a mesh. And a mesh is essentially just our representation of a 3D object. And it consists of a geometry which defines the actual 3D shape. So in this case, we've got a cube geometry, those are the dimensions, 50. And a material. And in this case, we just want a basic material that we're going to apply our texture to. And we add that into the scene. So now we've got our cube, we've got everything else ready, so we just need to actually animate our cube. So we've got an animate function, and each time that gets called, we're just going to change the rotation of the cube, and then call on our WebGL renderer to re-render itself. And then we use request animation frame, which I guess many of you are familiar with. It's basically saying to the browser, call this again when you're ready to render the next frame. And hopefully, what we'll reach is about 60 times a second, so we'll be getting 60 frames a second. And then we just will animate ourselves the first time just to kick it off. So here's how that looks. If I can click on that. Here we go. So yeah, got ourselves a 3D spinning cube. There we go. And not that many lines of code this time. So now I've introduced 3GS, I would like to talk about using it with React, because that's why we're here. So I'd like to tell you just a bit of a story about a prototype that we worked on in our team called Project APOC. And the idea was to have a tablet-friendly interface for learning about geology. In this case, specifically about plate tectonics. And we learn about the convergent boundary. And I will show you a demo video of that too, which I'll skip through. I won't do the sound, but you can see that we just have a home page here. And we click through from that, and we've got a 3D scene at the bottom. That's our interactive 3D model, so we can spin that around. that works with the mouse and the touch screen. Those labels are actually in the DOM, and they're sort of overlaid on top of the canvas, and we just update the position of those based on the things that are in our 3D scene, where those are. And then you can see that it's inside a kind of containing web application that we can step through on, and there's different modes that this enables and disables. At this point we've got a spot sampling tool, so we can read some data about rocks in different places. So hopefully that gives you an idea of what we were creating. So this is how I thought to approach it. I've created 3GS demos before that are standalone, and I thought, well, hey, to start with, why don't I just, in componented mount, when I know that we've got our DOM ready, we've got our canvas element, just actually call on a separate 3GS module, which is basically, like we saw earlier, handles its rendering itself, and we can just pass in essentially our canvas that we have from DOM rendering, from React rendering into the DOM, and then just allow the 3GS scene module to handle itself from there. It can set up its WebGL renderer, like I showed before, kick off its own animation and handle rendering everything inside of that canvas. And that worked, which was nice. I thought there might be something more to it than that. There was actually a few things more to it than that, because one thing I realized is that in my rush to, my enthusiasm of seeing this working, I forgot to actually think about what happens when I change the page and then my canvas is no longer in the scene, because I'm clicking to another page that has different elements in it, maybe the home page I'll click back to, and then there's no canvas. So what's going to happen then? And I was kind of surprised that actually it didn't break anything. My 3GS scene module was still happily just calling animate every 60 times every second, even though there was no canvas to actually render to anymore. So one thing is probably important to remember is don't forget to actually stop this and tear it down in the will unmount method as well. Another thing I ran into, so in this same situation where I say click back to another page that doesn't have the canvas in it, and then I go back to the page with the canvas in it again, I was reinitializing my 3GS scene, but I hadn't actually gone to the trouble of reloading all the textures, because hey, once you've loaded in the textures, you've got them, right? But it turns out that you can't use textures, you can't reuse them across multiple WebGL contexts. So in this case, WebGL gives you a nasty error and you don't see your textures on the page. And so it seems that the best thing is actually probably just to reinitialize everything. Then, kind of, I guess a more significant problem than that was just the sort of code mess that I ended up with, really, which was because I had these kind of different communication going on between the React component and the 3GS scene. So the component was kind of calling on the 3GS scene to run animations like it does at the start, where it kind of does a stock animation for you, and to change the mode into different modes. And then, because I was actually handling all the interaction with the 3GS scene within the 3GS scene module, then I was actually finding that I had to call the React module back as well, the React component, to say, actually the scene's changed position, so you need to update your labels and those kinds of things. So it all got a bit yucky. So I started thinking about how else we could approach this. This was working fine just for our prototype for a proof of concept, but it wouldn't be a way I recommend you all to do it today. So I started having a look around, and one thing I came across, which I thought was very cool, is a demo, well, actually no, a product from a company called Body Labs, which is a body mass index visualizer. And this uses React and 3GS. Let me just bring it out. Do this. Oops. Oh, and you can see you've got a nice 3D model there on the right-hand side. That's the 3DS model. And you've got your React controls there on the left, some inputs. And as you change those around, it updates your 3D scene. Pretty cool web application. And so I reached out to the developer behind this, Paul, and he told me a little bit about how they developed it. And so one thing to note, obviously an improvement from what I had, is that in their case they just have one-way communication. They're only calling the 3DS mesh viewer to render some output. They're not actually calling anything back on React code again, so that's obviously a nicer way of doing it. And also, an interesting thing that he shared was that they're using SetState on the React component to actually apply all the changes to the 3DS scene as well. So when they have new geometry or new vertices to apply to that body model, they actually call SetState. That will call React to render the component again, but your canvas will stay in there the same. And then in component div update, they were actually then using that point to apply the geometries and the vertices to their actual 3DS kind of view of the 3DS wrapper. So I thought, well, this is interesting. I mean, this feels more React-like in method. But Paul also said that they wouldn't do that again because it seems like a bit of a fudge to use a kind of React concept when you're not actually really using it in a React way. So what you would do next time is actually just have an explicit API on that 3DS module and say, hey, set the geometry, set the vertices. So that brings me on to the next thing I found in my travels, which is a library called React 3. And this, I think, was really what I was looking for, because it's specifically a library to give you React bindings to create and control a 3D scene using 3GS. And I'll show you what the code looks like on our side. It means that we can actually write our React component like this. We can simply define in JSX here our 3GS scene as a nice component there, a nice element. And we can apply properties to it, like our width and our height, set our camera name. And inside that we can set our perspective camera and our, in this case, a robot model. And just show the actual robots in a minute. And so it feels like a nice way of spinning up our 3GS scene in a way that feels React-like. And we don't have to then worry about this whole life cycle and this whole 3GS rendering itself. That's done for us through the actual scene that we've created here, and that's handled for us by React 3. And then just to share, so obviously you don't have to use JSX, so you can write the JavaScript directly, and this is what it would compile to. So I did a little demo with React 3 to try that out. And let me try to show that to you. Is this one? Yeah. Okay. So we like robots in the Future Tech team. So there's a couple of robots in this robot viewer app. And here's a scary-looking mechanoid, or you can switch to the sort of friendlier-looking Robbie the robot from Lost in Space there. And you can put these React controls at the top that you can spin left or right. I mean, they're input elements that are spat out by React. And you can change the spin speed and get it to dance. So, let me share a bit about the code to create that. Hopefully nothing too surprising, because it kind of just follows on from that code snippet that I was showing you earlier. I'll just zoom in a bit here. Hopefully you can see that okay now. So essentially we've got an app component, which is our top-level component. Inside that, we've got a controls component, which is our controls bar at the top, and the scene component, which is the actual 3D scene underneath. So we can pass in our properties to that. We take those from the state that are on this top-level component. So state obviously being things that can change over time, or the user can change. So that's the robot and the spin direction and the spin speed. And then the controls is very simply just a header with a couple of radio groups and a range inside it. And then we've got our actual scene bit here, which I actually still have just the JavaScript method here, but you can see that I'm creating a React 3 scene, I should say, passing in some properties and passing in some child elements there. And then that's essentially it, really. The rest is just in the normal way you do a React app, with some events to listen to when you change the inputs, and then you apply the changes to the scene element through the properties from app.js. So that is a code example that I've got on GitHub in case you want to try out React 3 and you're looking for a place to start. The guy behind React 3, Gary, also has some examples, some simple examples inside the GitHub repository for React 3. And that's kind of it. So just to summarize up, I wanted to share with you all that WebGL is actually well supported now, so it's really feasible to start using this in your web apps. And you don't have to create a whole 3D environment, a whole 3D game or anything like that. You can use it just in places where it makes sense and drop 3D elements into your apps. And you can integrate it well with your existing React apps. So that's it. Thank you.
Thank you, Peter. Has anyone got any questions?
I was looking at your geology scene before, and you said that you could change pages between while using it, and that it would not load the textures, right? So yes. I was wondering, when React stops actually rendering the 3C, will it actually take up, when you go back up to the page, will it take back from the part, the situation it was in? Imagine you rotate the view or change something there?
Well, that is a good question. So your 3JS component, if you still held that, will still have your old state, I guess, yeah. What I was actually doing each time I was coming back to a page with the canvases was reinitializing everything, so I guess I never really saw that. One thing that was interesting, though, is that at one point I thought, maybe I should actually reuse this canvas rather than kind of create it again every time you kind of click back and forward. So I tried this hack for a while that, again, actually worked, but I didn't really like it, where I would save out the canvas, essentially, when you move away and the canvas is about to disappear, because component will unmount, you know that you're about to get shut down. And I spat out the canvas element then just into the body and hid it. And then when I go back to the page that has the canvas in it again, I kind of just split it back in again. And that meant I didn't have to reload the textures again. And so in some ways that would be more efficient, of course. But I just felt a bit too bad with that being quite so hacky, so I took it out again. But I guess there are probably some interesting things you can do around that in terms of optimizing that. So yeah, an interesting area to explore a bit more.
Thanks.
The robot models, they look great. How did you create them?
The actual models?
Yes.
Oh, I found them. They're open source ones. They're shared on a website called Blend Swap, where people share models that you can load in Blender, and Blender is a free 3D model editor as well. And then from Blender you can export out to, there's a 3ds exporter for Blender, which spits it out in a JSON format that 3ds can read in. Or you can export it out to something else like Wavefront, OBJ, and then there's a converter that takes it from OBJ to the 3ds model. I actually used that myself because I found that worked better for me. So yeah, they're online and they're included in the GitHub repository if you want to use them for anything.
Thank you.
Thank you.